So 9C is all about line graphs. A line graph is a connected set of points joined with straight line segments. The variables on both axes should be continuous, meaning continuous numerical data. On the horizontal axis is often time. So we have a graph here. Yeah. No?
I'll have time to set my
Go. We have an graph here given to us for this first question, and we want to read some things off it. So the first part A says, what was the maximum temperature for the day? So we read the heading. It says temperature reading during one day. So this is just for one day. The temperatures. You guys are reading that over here.
It's just weird.
We'll talk about it later. Over here, the temperature starts, a bit below 20 degrees here at 4 a.m. Temperature increases during to the middle of the day, and then it starts to decrease again. So the highest temperature that it gets to is this highest point here, and it said, what was that maximum temperature? So as best we can, if this is 30 and this is 35, what do you think that is? About there. 33. I would say 33. Okay, so I'm going to say in that one there, 33 degrees. And this is degrees Celsius because it tells us the units on the left hand of that axis there. What was the minimum temperature today? That means the lowest temperature. So looking at these dots, this one's the lowest. Looking at this scale, 18. What do you think that is?
18.
18?
19.
I would have gone 19. But it is, it's not a very accurate scale, so just be as close as you can. What is the difference between the maximum and the minimum temperatures? So we take the maximum temperature, which was 33, and we subtract off that smallest temperature, which was 19, and that means that there is 14 degree difference throughout that day. Right, that's question 1 done. On to question 2. We have another graph, and it says Beth's weekly income for the heading. So on the left-hand axis, please. On this axis here, you can see her income. So this is $500, $600, $700, $800. And across the bottom, we have the year. So her pay is obviously changing over the years. And fortunately for her, it is increasing. So that's a good sign. So the first question is, what was Beth's weekly income in 1996? So 1996 is this one. Her weekly income, we go to the dot, was $600. Question B, in which 2 years did her income stay the same? So the flat line indicates no change in her wage, which was from 98 to 99. By how much had Beth's income increased over the period from 1996 to 2001? So 2001, at its highest point, her wage or her income was $800. At 1996, the start, she was earning $600. And we want the difference, which is why I have subtracted them. So over those years, that's an increase of $200. Okay, next, we obviously don't just read the information off the graph, we have to make one ourselves. So the data is given to us in a table, and it's the number of car thefts in Melbourne over 6 months. So we've got the month of the year, and we've got the number of car thefts. The month. Which axis should that go on? The horizontal one or the vertical one? Correct. Horizontal. Okay, because that is time, okay, which is going up by a constant amount. We're going up every month. that goes on the horizontal axis. So because there's only 6 months there and I have a lovely big piece of grid paper, I'm going to use every second space just to help spread my graph out a bit. So I've got January, February, March, April, May, and June. Okay, then my vertical axes, looking back up here at my table, the biggest number that I can see in there is 30. Is there 30 spaces on that vertical line that I've just drawn there? Can I fit 30 spaces in there? No. So I have to go up by 2s to fit that in as well. So 2, 4, 6, 8, 10. Okay, I have got a scale on each axis, but remember that you also need to label them with a heading. So this one was the month of the year, and the vertical axis was the number of car thefts. So NO with a dot means number of car thefts. Okay, I haven't drawn any part of my graph yet. There is one other thing I should do to make sure I don't lose any marks on my test. Can anyone remember what it is? The title. Perfect. What should I use as my title? So the heading on the table says number of car thefts in Melbourne over 6 months. Probably don't want to write all of that out. How about just car thefts in Melbourne? You can write the whole thing if you want to, but as long as it has some kind of heading that relates to the topic, I am happy. Okay, remember you've probably got a couple of marks just for getting your axes properly set up. A nice consistent scale, labelled axes, and a title. Now we want to draw our actual graph, so we want to put the points on there. So with my table on there, my first point for January was there was 30 car thefts. So above the January, put a dot or a cross, you can use either, up at the 30. Then February was 23. You want to be nice and accurate, make sure you get them in the right places. March is 28. April 22. May 17. And June is 25. Okay, so it's a bit up and down. So each one of those dots, we have to draw lines between them. Okay, so you get your ruler and they've got to be straight lines. Please don't try to freehand it. It'll look like a mess. Rule between the dots. It's always a good idea to draw graphs in pencil because you can erase mistakes. If you are doing a graph in a test and you have to liquid paper something out, all of a sudden you've lost your grid paper as well. It's a bit of a nightmare. So I strongly recommend that you draw your graphs in pencil. Okay, so there it is. Graph is done. Okay, there's a couple of extra questions down the bottom. Okay. For B, during which month were there the greatest number of car thefts? Which month had the most car thefts, that means? Yes, Anton.
January.
January, excellent. The first one was the highest. And C, during which month were there the least number of car thefts, Cash?
May.
Yes. So you're just looking for the highest point on the graph was in January and the lowest point was in May. Easy as that. Okay, do we have any more on the next page? Yes, we do, a little bit more. One more example. Question 4. This is a travel or a distance time graph. It shows the distance traveled by a cyclist over 5 hours. Now, for distance time graphs, they're a very special type of graph that you can tell a certain amount of things just by looking at the graph. First of all, if you have a flat section in that graph, it means that the person is stopped. They are no longer moving. They're stationary for that time. The slope of these lines also tells you how fast they're traveling. The steeper the section is, the faster they're traveling. This would be slightly slower because it's not quite as steep. Okay, so let's answer some questions. 4A, how far did the cyclist travel in total? Well, starting at time 0, we're here. We've travelled no distance, okay, time 0. By the end, we have travelled
15.
Nope. 30 kilometres to get to the top. How far did the cyclist travel in the first hour? So that means from the start to 1 hour, they've gone from 0 to 15 kilometres. So they've travelled 15 kilometres. C, what is happening in the second hour? Okay, I mentioned this. If it is flat, it means that they haven't travelled anywhere. So you just say there that he is stopped. He stopped somewhere. Or rest, yeah. When is the cyclist travelling the fastest? Remember, that's the steepest slope, which is, Anton?
Hours 3 to 5.
Nope, that's not as steep as this. So the steepest part is here in the first hour. So between time 0 and time 1, or the first hour. And in the 5th hour, how far does the cyclist travel? Now, this was from there to there is the first hour, 2nd, 3rd, 4th. The 5th hour is from 4 to 5. Okay? So at 4, we are at 25. And we get to 30 by the end. So how far have I gone?
5 kilometres.
5 kilometres. Okay, pretty straightforward.
5 kilometres.
Because in the 4th hour is from here to here. So that's from 25 up to the 30. Okay, your turn, your questions.